All right, we get to talk about arc measures. So our goal is to learn how to find the measures of angles and arcs using properties of circles, and also how to find arc lengths. So first of all, we have to understand the concept of a central angle. And so a central angle is an angle that has a vertex that is the center of the circle, and the sides are radii of the circle. So angle ABC, or angle CBA, is what we call a central angle of circle B. Remember, circle B is named that way because the center of the circle is B. So it makes sense that we would call this angle a central angle, since the center is its vertex. A degree is 1/360th of a circular rotation about a point, and 1 degree doesn't seem very large. You really can't tell how big it is until you stretch it way across a paper. So take that times 360 and we cover the whole circle. So when we have central angles in our circle, the measure of angle 1 and the measure of angle 2 and the measure of angle 3 all together have to add up to 360 degrees. So next we need to talk about what it means to be a minor arc, a major arc, and a semicircle. So we have the same circle here with different segments inside. The larger circle, circle A, has an orangish color area, and that arc between C and B around the outside of the circle is called a minor arc. And the reason it's called a minor arc is because its central angle is less than 180 degrees. So it's less than a straight line. So we call that a minor arc. And we have major arcs as well. A major arc is an arc whose central angle is more than 180 degrees. So this angle, CAB, this way, is more than 180 degrees, is more than a straight line. So this is the first time we've seen an angle that's been larger than 180 degrees. And then if we are working with a radius, a diameter of a circle, then we're working with a semicircle. So because this chord EB goes through the center A, then EB is a diameter of the circle. And anytime you find a diameter of a circle, that means that you've cut the circle into 2 equal pieces. 1/2 of that circle is a semicircle, and the other half is another semicircle. So how we name these arcs is by using either a 2-letter name or a 3-letter name. When it's a minor arc, we are going to name it by a 2-letter name. For example, arc BC is a minor arc because it went the shortest path between B and C, and that was less than 180 degrees, so it's a minor arc. So it uses 2 letters to name that arc. But BDC is a major arc because that major arc covers from B through D all the way around to C. That was more than 180 degrees for its central angle, so we name it with 3 letters, major arc BDC. So you can immediately tell if something's a minor arc because it will only have a 2-letter name, but BDC is a major arc, and semicircle BDE, starting at B, going through D, ending at E, is also named with 3 letters. It's a semicircle. So when you see 3 letters, it could be a semicircle or it could be a major arc. You have to determine what the central angle is to know which one it is. So let's talk about example 1. The measure of a minor arc is equal to the measure of a central angle. So we have the center of the circle at C. The vertex of this angle, ABC, is the center. So ABC is a central angle. Since the central angle has a measure of 50 degrees, the measure of the arc AB around the outside of the circle from A to B is also going to be 50 degrees. Well, if the measure of this minor arc is 50 degrees, how would we find the measure of the major arc between A and D and B? Well, its central angle is more than 180 degrees. Remember that a whole circle is 360, so if we take 360 minus the 50 degrees, we will end up with the major arc's central angle, which is 310 degrees. And that means the measure of that major arc is 310 degrees. Math is easy, it's just a matter of keeping track of what all the notation means. For example 2, we want to find some more central angles using the value or figuring out the value of x. So x is a major or minor arc. It's less than a straight line, so it's a minor arc, a minor angle, so the DE is a minor arc. And when we want to figure out what x is, we see that we have an 85 degree angle, a 40 degree angle, and a 90 degree angle. So if we add 85 and 40 and 90, we will get 215. And then take 360 minus the 215, and we get 145. So the value of x is 145 degrees. And minor arc DE has a measure of 145 degrees because the central angle and the arc are the same. All right, for example 3, we're going to classify our arcs and we're going to find the arc measures. So first of all, they mentioned that PM is a chord that also happens to be a diameter. Goes through the center of the circle, circle R. And we want to identify each arc as a major arc, a minor arc, or a semicircle. Well, first of all, the minor arc MQ has to be minor because it's listed as a 2-letter arc. So from M to Q is going to be this arc. So we need to find out what its angle is. But remember, they told us we have a diameter. So if a diameter is on our circle, then we have a semicircle. And a semicircle is half of a circle. So 180 minus 115 will be the measure of our remaining angle here, MRQ. So 65 degrees. So if the central angle is 65 degrees, the measure of arc MQ is also going to be 65 degrees. Then we check out arc MNP. MNP goes from M through N over to P, the shortest path between them. And since this was a semicircle, a diameter, then MNP has to be a semicircle, and it has to be 180 degrees. And finally, they ask us to find the measure of arc MNQ. So starting at M, traveling around the circle from M through N and ending at Q means that we're using almost the whole circle except for this 65 degrees. So 360 minus 65 degrees. Well, 360 minus 60 degrees would be 300, minus 5 more is 295 degrees. 295 degrees is more than 180, so this is a major arc. All right, the last concept we need to talk about is arc length. And when we want to know the length of the arc, we're asking what is the portion around the outside of the circle. So not the central angle measure, not the measure of the arc, but how much material would it take or string would it take to wrap around that portion of the circle. So it's the distance between the endpoints of an arc. And we measure it in linear units, like centimeters or inches. And so, since it is a portion of the circle, instead of finding the whole circumference, we're finding a part of the circumference. So, in words, the length of the arc, and we like to use the letter L, for example, you can use X instead. So the length of an arc is a ratio of the arc length to the circumference as the degree measure of the central angle is to 360. So a couple of ways of thinking about that. You can say the arc length over the circumference, L over C, equals X over 360. Or X degrees out of 360 is the same thing as the arc length over the circumference. Sometimes we'll give you a radius, so you'll want to use 2 pi r. Sometimes we'll give you a diameter, so you'll use pi d. But the angle measure over 360, the central angle over 360, is equal to the arc length over 2 pi r, or pi d. A different way of looking at it is you can say, well, I'm not really finding the whole circumference. I'm only finding out x out of 360 of the circumference. So it's a fractional portion. X is to 360, or x over 360th times 2 pi r, or times pi d is another way of calculating this. So we'll look at it both ways. If we want to find the length of arc AB, AB is the arc is starting at A and traveling around the circle to B. So we don't have a whole circumference, we have a portion of the circumference. How much of the circumference do we have? We have 80 degrees out of 360 degrees. So if we use our equation, the arc length is 80 3/60ths times the circumference. Or the arc length is 80 3/60ths times, in this case, 14 meters is our diameter, so times pi times our diameter. So we can take 80 divided by 360 times 14 and then put pi at the end to leave it in terms of pi, or we can multiply the pi in. So 80 3/60ths times 14 is going to be equal to 3.1 repeating. And if we want to multiply that by pi, we could get 9.77. So 3.1 pi, or 9.77. That's the arc length, and you can use it X instead of L if you prefer. The other way of setting it up is to set up a proportion. So if we want to set up a proportion, we say 80 degrees is to 360 degrees as our arc length is to our circumference. Or 80 degrees is to 360 degrees as our arc length is to 14 pi, since our circumference is pi d when we're given the diameter. Or the circumference is 2 pi r when we're given the radius. Well, you've done enough problems with proportions that you should know that we can cross multiply here to solve for L, or since L is being divided by 14 pi, we can simply multiply both sides by 14 pi. So if we multiply 80 times 14 pi, we will get 360L, and we'll divide by 360, and we will get the same result. So 80 times 14 pi divided by 360 3.1 repeating pi, or 9.77. So same result both ways. It's Just depends on which way works best in your brain, which one makes most sense for you. You can leave it in terms of pi as far as I'm concerned, or if you want to have a better idea, 9.8 meters. All right, last example. To find the length of arc PQ, same process. I want to know how much string would I need to wrap around the circle from P to Q if I unrolled that. My central angle is 45 degrees, so setting it up as a proportion, 45 degrees goes with 360, as my arc length goes with the whole circumference, but this time 3 centimeters is the radius, so I need to use 2 times pi times 3, 2 pi r, as my circumference formula. Or if I prefer, I can write my arc length equals 45 3/60ths times the circumference, 2 times pi times 3, whichever works best in your brain and makes the most sense for you. So we will take 2 times 3 and get 6. 6 pi times 45 divided by 360. Gives us 0.75 pi, or 2.4 centimeters. Very small portion of the pi and a very small radius is going to give us a very small arc length. All right, so your assignment is in your packet. They followed the examples as they are listed up there.